There is no sound, says, yeah, hey, man, thank you. There's no sound. Well, sound, it's just my voice. I guess this would be a better value to use here. Oh, coincidental special number. No. Yeah, this is really a 3D, three-dimensional object, which I'm now rotating. Can you see it? Since it is three-dimensional, maybe, you know, like clearly, this point is in the back, so this is in the front. So this goes deeper into the screen. Definitely would have been better if that was visible, more visible, better visible. Hell, I could just fill this with a color. Have it a little bit transparent, but not that much, so you can almost not see this line. Then it would be super clear. That means that we have to find all polygons that are traversing cubes. Yeah, that ain't easy, is it? Oh, just ask AI and let it go, and maybe it will work, you know? I'm not sure. I mean, I don't have support in my drawing library for coloring in a polygon. Let's first talk about what polygons are in the first place. So like this is a polygon. This is one. And that is the case because, well, we have the green intersection points on the edges of the tesseract. And we have lines in between them. So here's another one. There's no point here, so there's no confusion, I think. But in the end, this polygon here is simply it belongs to a cube. It belongs to the intersection points on this cube here. This cube. How many of those cubes do we have? I think we have 8 cubes. A cube is on the outside of a given axis, and so one axis has 2 outsides. And then we have 4 axes, so you should have 8 cubes. Those are easy enough to find, I think. And then if you have a cube, then you have all the edges that belong to that cube, and then we can find all those intersection points. And then we have the polygon. So we have at most 8 polygons. How many do we have right now? I mean, it's like 1, 2, 3. Okay, it's difficult. You can see it if I do rotate it a little bit. You can go around like that. That would be the big ones. So it's 1, 2, 3, 4. And then there's 2 there and 2 there. So I'm counting 8. That that is the maximum. Yeah. And then for example, I make that 7 by changing this. So this one here is now disappearing. We can get smaller, smaller, smaller until it is no longer there. It just means that this cube here, or the face that where this cube is, the cubes that have this face here as a 2 face, that doesn't have an edge anymore. So we find a cube where this belongs to, for example, this cube. Then that should have no longer a 6-pointed polygon, and clearly doesn't. It's just a square. And there should be another cube that shares this face. That is going to be this cube here. Yeah. And that one has 1, 2, 3, 4, 5 edges. Instead of 6. Let's talk to the AI. I should probably first commit to this. I'm gonna go to math first. Is anything changed here now? Nothing has changed there. That's good. So I only changed what was a new commit, so let's push that. Can't type, get push. And actually the infant source has changed. Really? Why? How? Yeah, okay. Commit. I changed my mind halfway in the sentence. Interesting. Add installed source, git commit. Yeah, well, sources. CPD files. I commented out a lot of stuff. Maybe I just want to delete it. Or a lot of stuff. Yeah, I commented out this because this code was duplicated. could be replaced with the lambda that we defined here. Now this code here is almost duplicated because it's doing the same thing, except it's doing a little bit more. It feels that. That is annoying. So maybe it should extend the lambda to also be able to do that if I pass something to it. So we're currently calling a lambda like that, and then if we want this lambda to also fill in the depth, what is this depth then? The depth is calculated as the signed distance of the hyperplane projection to the window plane. This is the depth. Okay, so this is the depth for the intersection points. Yeah, of course, they exist as well. So I could pass corner depth to 1 and say intersection point depth to the other one. This just make more of them. Haha. So I'm gonna edit this file. Let's say VI tesseract CPP. So I have a corner depth, I think, and we are going to add it's a corner index. Never mind, let's first investigate how that works. So the corner depth is filled here from the corner index which we are running over, and then in another case where this lambda is being called, I'm still calling it. I'm doing the work twice now. Yeah. What? This function returns a window plane project. So that would be this one. So I think this value is exactly the same as what this is returning. Might as well use that, but okay, we're going to change this anyway. And here there was another code duplication. That also runs over no, wait a minute. Intersection point. Okay, this runs over intersection points. Then we don't have an index, or do we? And this should be also a vector, probably. Yes. Oh, the type of this thing is something returned from intersection points. Now, in order to keep those things apart, like so, we have a list of corners, that hypercube corners, and those things have edges. And if you make a list of edges, then, well, an edge is not a corner. So in order to, and on each edge has an intersection point or not. So you would have a number of edges, which in this case would be 32 edges, I think. And then you have a number of intersection points, which varies from 4 to 32. And we can run over all of them by index, but those indexes then really belong to the type of thing that is being stored. So you have a corner index, like here, and that has its own type. But for example, the thing that is being returned here, that would not be a corner index, of course. I mean, this is a vector, but the index of that vector is definitely not a corner index, because it doesn't store corners, it stores intersection points. So what I would like to have is a vector that also has its own index type, and then I don't call it corner index, but we'll call it intersection point index. However, currently intersection points here is returning a standard vector. So now I'm thinking, let's change that to return a utils vector, which can have its own index type, which then should be defined by math rather than the other project where we came from. Hence, I first have to change this, which is the the math library. And all of that is defined in hyperblock.h. So somewhere in hyperblock.h, I have to define a type for the vector type, which then automatically also defines its own index type. And I think it makes sense to not define that in global scope, but define it just as part of the hyperblock, because this is a member function of the hyperblock. So we find the hyperblock class. And then we define an index type here. So that would become something like, let's put that at the top then, using intersection point index. Yeah. And I call that then utils vector index. And you have to pass some stuff here. Let's have a look. Vector index takes a category. It can be any type. So I could just pass, I don't know, just hyperblock itself. Unless, of course, the hyperblock returns multiple lists, then that would be confusing again. So theoretically, I should use a category that just spells out that these are intersection points. I'm not sure I have a type that is even related to that, though. Let's make it. Otherwise, it's maybe a little bit. Could use edge here. That is, well, it's something on an edge. Well, like I said, we have edges, and then on some edges have intersection points on them. So maybe maybe that's just not the same index. So also edge would be very confusing. I could use edge to enumerate all edges. But in this case, I'll just make a new category by defining some enum or random type. And we call that intersection point category. It's just some type. Can the thing be empty? I think so. So we pass this as category, and now we have an intersection point index. Then we have to define the intersection point vector. So we can do section points. Is utils a vector, And then the thing that we store in it, and that is going to be the same thing as is currently returned from intersection points in the standard vector. So that's just vector type. But then for this vector we use that index. So if I search now for standard vector type, that's one, and that's probably all of them. No, wait a minute, there's more. But these are also intersections. Breadth first search takes it. Interesting. So we return it and we pass it as a parameter. And this is just a definition. So this is going to return intersection points. Yeah, these are intersections. I think you just pass all intersections to breadth first search. All of those were intersection points. And I just noted that I'm calling this intersections instead of intersection points. I think I did that because I thought that the word intersection point was a bit long. I definitely want to be consistent, so maybe I should remove point everywhere. Did I ever type lowercase intersection point? I did. Well, that's the function call. Yeah. That's about it. Oh, there is an intersection point here in edge. Maybe I should add point to all the other intersections. Or intersection, and I mean, it's not an intersection, it's an intersection point, I think. So we have intersection followed by anything but a P. Doesn't exist. Intersection followed by anything but an underscore. That's not too many of those. Then it is also a point. This should just be intersection point. Intersection points. Plane intersection. What? Plane intersection, that is defined in hyperplane. It's not renamed that yet. Did we go around already? I think so. Yeah, that intersection was the only one left. Last one left. So now we have an intersection points type. Intersection point category. Intersection point index. Intersection points. Intersection index. Intersection points. Looks good. That thing now, well, the intersection points anyway, does no longer accept an int as an index. So when we try to compile this, then it won't compile. And either we can be lazy or we can just try to do this before without compiling. Let me try that. So this type here needs intersection point index as index. Where do we define that? Well, this just returns it. That just takes it. And here's one. That is the intersection points function. And then we have the as an argument to the breadth first search. So that's about it. Okay, so we go here. Two functions. This is one. And here we pass it simply to breadth first search and return it. Seriously? That doesn't make any sense. Oh, the breadth this is an output actually. Okay. It's passed as a reference. Yeah. So this is the one that fills it. And then we're done. So the only function that needs changing maybe is this one. And that uses mplace back. Well, that's still going to work because it's not using index at all. I don't see int being used there. I think it just compiles directly. So it's like done here. Right, okay, so now we are back. No, we're in math hyperblock. Oh yeah, of course, the return type has to be changed still. I was looking for standard vector or something, but this one has, yeah, I didn't find that one. There might be more of those. So, standard vector type or something, yeah, maybe type name, maybe, I don't know. Let's just search for something more general. Something with vector type. No. Oh, that's only the only thing? Why? How? Oh, because I already replaced all the others. Yeah, that is the only place then. And this now should become intersection points. But it doesn't know what intersection points is here because it is a type defined by the hyperblock. So if you do it like that. And yeah, it's a type name. You have to pass that here because it's inside a template. And that replaces this. And of course, what is probably, no, it's already done. Intersection points declaration already returns the same type. Now we're really done, I think. Now back to source tesseract.cpp. Here we are calling it. So now this auto type is changed to an utils vector that takes in tesseract hyperpoint index as index. And since intersection points WC has the same size, well, it even stores intersection points. Also, this vector now must be of that type. Except that here we store a math vector. Instead of vector 2, I mean, instead of a vector 4. So this becomes utils, capital V, that same thing with the, yeah, the intersection point index. It was actually defined in the hyperblock of the tesseract, and I don't want to repeat that, so we just have to define this thing somewhere else, like the corner index, I guess, or near the corner index, if that is defined here. No, it's not. Corner index is defined all the way here, because we needed it here. But it doesn't seem to be the case. I'll add it here. Using intersection point index is the hyperblock intersection point index. And that hyperblock is the type, that is the type of tesseract. It's just a moth hyperblock. I think I'm going to spell this one out as well. The auto is a bit not revealing enough anymore, maybe. So this is the same thing, except that it returns four-dimensional vectors. Yeah, I think so. Yeah, and of course it's just you see here universe coordinates, so that's four-dimensional. That is window plane coordinates, and the window itself is two-dimensional. Now, see what influence this type change has on the intersection points WC. Reserve, that still works, of course. Push back, that still works. And that's it. Well, we run over everything, but that also still works. So no problem there. We're not even using the index type. We're not ints. We're not using indexes at all. Just running over a range without using index. I'm starting to lose my overview what I was doing, so maybe it's time to start compiling and then fix all the compile errors that this still might have caused. The phenomenal intelligence. Well, you're at the right place for being intelligent. I just changed the type of intersection point related vectors to a vector that only takes intersection point index, and then some abstract type wrapper around the size type. But yeah, I was doing, damn it, I was doing something and then I interrupted myself while doing that to do something else. And I forgot what I was doing before the interruption to change this type. That is so annoying. So maybe I remember though. Yeah, I was working on adding this lambda here to get rid of code duplication. Okay, so we have this project universe coordinates to window coordinates lambda, and that would work here, I think. Now I remember. Yeah. So I'm going to pass another vector to the lambda, which has a different type for different things that we run over. Namely, in this case, I want to have a corner depth being filled. So let's say I'm not going to do this, but I'm going to pass an extra thing, corner depth. That would make my lambda a template. Is it even possible? Probably not. Probably well, you can use auto, which is also a template, but it's kind of more like a hidden. So this is a depth array, depth, and it's also an output thing. So I have to pass that as a reference. Auto by itself is never a reference. And then I want to do whatever we do here. That is, before returning, corner depth becomes depth, except that now it's not always a corner. It's called depth now, and depth itself was this, which is the window plane signed distance. So for some reason I don't see here what is going on. Oh, here, window plane project. No, that is before the project. This a new line. This between the window plane, which we have here as well. So that is window plane, yep. And that, which was just calculated as being the hyperplane and universe coordinates project, which I do have here. Okay, so I can repeat this line here, because we do have window plane and then signed window, and then whatever was just, I mean, that thing is this and that is this actually. So now it's we don't know what it is, so I just call it point in hyperplane coordinates. And that thing I want to assign to the array at some index, but that index is this index. So you have to pass the index as well then. Might as well pass a reference then. So I'm gonna call this depth. And it must be an iterator. Can now be a const reference then, and it's depth. I'll make it clear that it is an iterator, otherwise it gets very confusing because of the auto. And then you have to pass an iterator. So instead of calling depth, I must pass. Well, actually, I don't know how to pass an iterator here. I can pass CI. So maybe I should just pass a reference, a non-const reference. I mean, this could be interpreted as a reference still. So that now it's no longer, it's just a reference. Okay. Depth reference. I'm not going to do that. I mean, the reference is already here. Well, let's call it depth out. Otherwise, you know, we know that it is the output variable. I think this should work. Quite a lot of those lambda usages, which now need a reference to a depth array. And yeah, so in this case we did already have that, so I can just pass it. But in this case, it's a hyperplane. Sorry, it's an intersection point, and we don't have an intersection point array yet. Well, this is the first place where I need that, but now I don't have the index here. Okay, I think I need the index, right? I think I need the index. So my intersection point and universe coordinates now becomes, well, it's from the same vector, but then some index here. And it is an intersection point index. Well, intersection point was always called P. And I is a bit short. Let's just call it intersection point index. And then here we're going to pass a non-const reference to wherever I want to store that in. That would be then intersection point depth. Let's go to, well, how do you call that here? That was corner depth. Okay, so it definitely has to end on depth. Depth, so that's the intersection point depth. Full or IP again? No, they just call it interception point depth, I think it is. With the same index. Oops, that's not the index, this index. Which means that we want to run over that index. And God knows what the type is, so that's going to be an auto. Is, now index have I begin of the vector that we run over. And then unequal I int plus that. And we were running, well, we are running over the hyperplane intersections thing. So that should do the same thing, provided of course that this is now a utils vector, otherwise ibegin would not even exist. And let's check that. Well, it should be, but let's check it anyway. Yeah, that is what is being returned from intersection points, which indeed is a vector, utils vector now with intersection points index. So this is an intersection points index. I don't even need an auto then, really. I mean, auto is nice, but sometimes if you just know what it is, it's just better readable if you do it like that. Yeah, it needs a comment, I think. So run over all intersection points. Okay, there's one thing missing still here now. The intersection points depth was new, so I need an intersection points depth, which is then a vector that accepts the intersection point index type, aka the exact same type as that we have here. Except that this vector doesn't store vectors to the intersection points, but it just stores the depth. And I think that that is float type or something like that. Must be the same thing as being stored in corner depth. Oh, it's stored as a double. Not really correct, is it? I mean, corner depth, like for example here, corner depth is filled with, oh, also double here. No, it comes from a signed distance. What is signed distance then? Signed distance is t. See, this is just bullshit. And the t is the second argument to the hyperplane. So really, it is the second argument of the type of window plane, which is defined as math hyperplane, which is deduces the type from actually I'm saying that it's deducing it, but this is main. Oh, it deduces it from this thing, yeah. Which has deduced it, which is a double, because I don't pass it. Yeah, so they can pass float here. I'm not going to, but if I would do that, then this thing here is being passed to this constructor, and then this constructor deduces its own type, because a hyperplane has a floating point type, and that it deduces it from the vector type that you pass to it. Because that must match, otherwise this wouldn't match here where you assign the thing. I forgot where it came from though. Oh yeah, and then we call signed distance on that. So it just is it's just a double, because I'm not passing anything to this first line here. Where was it? Okay, I'll just use a double then. What is a double? Okay. So now this vector is going to be filled by index, so it must have the correct size. So we must call reserve on it in advance. Oh, not reserve actually. I must set the size, of course. Might as well construct it with the correct size then. I think if you just pass the size type, then that is the size. Yeah, I think this vector is just using the constructors of what is this? Math. This is math vector. Let's go to utils vector. So it uses the constructor of the base class, which is just a standard vector. I can never remember if I think if you just pass a size type, then that is the size. And then the stuff in it gets default constructed. I'm not even sure then these are zeros, but maybe uninitialized. Probably filled to 0. It doesn't matter because we're going to assign all of them. Yeah. Now, what is the size? Well, that would be the number of intersection points, which of course is the size of this thing. Call it an array, even though it's a vector, because we give it a fixed size. Actually, I think my utils array, assume I delete this and type in array. Maybe I should. I have to change it back, but now I can jump to it. So my array, utils array, also takes an index type, and that is interchangeable with the index type of the vector. Or not. I'm now doubting actually. Well, if a vector has the same size, then it has to be the same size. Otherwise, you would never be able to interchange indexes, of course. But probably possible. However, we can't do that here because the size is dynamic. This is the size here. Well, this call here is dynamic. Now I happen to no, I don't happen to know anything. I mean, I know there's 32 edges, but the number of intersection points depends on the slider values. So we must use something dynamic, so that's a vector. I'm still going to call it an array though. And then there were even more usages. Here, that's the last one. These two are the last one. And these store face intersection. I think that is. I think that's the same thing actually. That's also intersection point, but then for a certain face. So the face intersections were filled with the values from Match filled with intersection. Doesn't feel right. Yeah, this code was generated, well, lots of code here is generated by the AI in the end. This passed my attention. Slipped, oh, no. I don't think this is correct. I think it recalculates an intersection point here. While we already know the intersection points. And it totally works, but I would rather just use, you know, the exact same values. Hello, OS name, Arch. Or is it not operating system name? Linux, GNU Linux. Yeah, Arch is a distribution, something else, I guess. So these are the line segments on the faces, the two faces, two-dimensional faces, right? The number is of course very variable. Totally depends on the slider values and the orientation of the normal of the hyperspace and the normal of the window plane inside of that. And definitely a different number of segments than intersection points, because those intersection points are a pair of intersection points gives us one segment if they are on part of the same face. So if I want to store this, I have to pass an array here and there separately, actually. Feels like I'm just redoing the same thing, because in the end this is going to be an intersection point. That it also belongs to a face, I don't care. It's just an intersection point on the edge of the tesseract. And I already enlisted all of those. There is no need to pass an array here or store anything in it. which makes me think, well, it makes us realize, right, that even this calls bullshit. Because we already did this. These values are stored by intersection point index, which now we have. So if instead of this I would have intersection point indexes, I could just get this value directly. Let's see. Yeah, so we have intersection points in window coordinates by intersection point index. And that's what we need here. So I want to pass really section point with some intersection point index 0, I guess. No need to have this array-ish. Definitely no need to call project universe coordinates to window coordinates again. And therefore also no need to pass an array, because, well, the depth was already calculated and already stored. That is the intersection points depth array, which you can just pass the same index then to get the depth here. Therefore, we want to have this. Instead of the face intersection in universe coordinates, we want to have the index that corresponds to that. So face intersections should be face intersections, face intersection point index or whatever. No, that's being filled here. So the question is, do we have here the intersection point index? We have well, here it's calculating an intersection where I was like, what? Why would you do that? Everything was already calculated. So what you really need to do is convert the A and B to an intersection point index. Okay, let's commit that this was written by the AI. I'm gonna let the AI fix it. Math was modified again. Oh yeah, we now have intersection point indexes. I have to commit it because otherwise it's untrackable what the AI is doing. aka is messing up. Even though I'm in the middle of stuff. Work in progress on... Yeah, well, I can't really say and only this. Because I might need a few other thing changes. I'd like you to fix this piece of code such that one, it doesn't call project UC to WC, but reuses the values already calculated that are stored in intersection points WC. See the comment. And hence we need to know IP index 0 and IP index 1 at that point, both of which are thus of type intersection point index. Hence, no longer should store math vector 4 but be renamed and store store the proper intersection point index. 2 don't call hyperplane intersection, which recalculates what we already did calculate. Instead, deduce the correct intersection point index from A and B. I think A and B are just two corners. I'm not sure what face edges contains, so maybe before I give this command I should investigate what the hell that is. Yeah, it's corner indexes on A and B. Two corner indexes. Two corners lead to an edge, lead to an intersection point, assuming it exists. So yeah, that is then the question, of course. How do we figure out what the intersection point, the intersection index is, given the edge, basically? I guess that means that that information must be stored in edge. Okay. So I suppose that means that intersection point index must be stored in struct edge. Note that intersection point index is a utils vector. I just said that, but okay. Which has well, how unlikely is that? That's a lot of code. Can hardly believe that is necessary. My God. And this is pure stupidity. Why the hell does it remove my if 0? It is just a comment. What? Yeah, no. Man, what is shit? This is bullshit. My God. Jesus Christ. Look at that. Jesus, how do I formulate this? Gut turning? Nauseating? Middle school grade. I'll just print 0.0.0. I mean, what can I do? What subscription do you have? Plus, do you pay enough for us to pay attention? What model are you using? This one. What platform is your computer? How the F is that relevant? What issue are you seeing? I asked the DOM model to implement a local change. I guess I have to describe why I think it is so bad. That is annoying. I keep pressing the wrong key. Why do I keep pressing Control here? Alt Tab. What is this? It does the following. It wants to have a map from two corners. Yeah, there we go again. Alt. Okay, what else? Yeah, there we go again. How often am I going to do that? Yeah, I guess I should add a link to the final codes. I'm hesitating to say like I'll show you later and then press create and then maybe lose my face completely by finding out that I can't do it even better. Anyway, it's definitely the safest to not press enter yet and start fixing this. Let's see if this code compiles. Doesn't even compile. Oh yeah. It is a completely unrelated application that also calls intersection points. And I broke that because now intersection points returns an utils vector. Therefore we don't have access to 0 and 1 anymore like that. Being the first and second argument. Hyperplane, I need to use our block. will I begin? I don't think so actually. Or is it? Is it detector? Thesis. Plot. Huh? I was confused with bit set. Yeah. I can create a vector index directly from a size type. Explicit, and it is const expression. Which that's what I have to use. Mm-hmm. Yeah, can you subtract it from 1? Let's first do this one. Index 2 becomes yeah, and then invert those two. So that is does it in a vector index? Can subtract from a size type a vector index, and that returns a vector index. No, I'm not sure anymore if it was explicit or not. Let's just try it out. So this should work if it is accepted as a size type here. Ambiguous. But does it know it was a side or well, the result is the same because it is a 1. Actually, might as well just use a second. Aha. Oh. So while the overloads, you cannot subtract two indices from each other. Well, at least I would definitely would not get an indice in that case. Size type 1 then. What? Why is that so red? Size type 1. Nobody knows where I edited that. Why is it not visible here? Coordinate system 458. Or is this commented out? Yeah. Okay. So it does work. That's good, I suppose. Map. Yeah, I don't want to use map, but then it won't compile anymore immediately. It's not restored it yet. Yeah, I do want to restore this, but I want to keep that one. So edit it. Editing it while restoring. That is very difficult. I mean, if I now comment this one out, then what is it restoring? The addition is removed, or what I remove is removed? To remove plus lines. I'm setting the page for yeah. I would say I'm editing the patch that is being restored. So I would normally comment out the map in order to keep the map. Probably not how it works though. I have to test it out, I'm afraid. That is the map line. So let's say see, to remove plus lines, make them spaces. So I would say a space means that I keep it. So I have to make a plus what I want to have removed. So this seems to be what I want. Yeah, well this is now the patch that I want to revert. Remove this line, so that we should still have the map then. Quit. Git. I think the restore is done immediately or not. It's now in the index. Div cached. There's nothing in the index. Yeah, I think I still have the map, so that worked. I want, this is not even a bad change actually, but this, I don't want that, so we have to edit it again. And then I want to delete the minus. Wow, how is that even possible to understand? So extremely scary. If I do a restore on the whole thing, it's going to do the inverse of this patch. And what I want is to do an inverse where the if 0 is restored. So this minus should stay. Then I reverse it. And here I want to keep it, meaning that so I should make this a space and delete this line. So this is a yes, because I think it's in the middle of the if 0. I do want to restore that. And I want to restore all of that. Should not have touched this. And we want to restore this. Should not have moved it nor removed the comment. And this is your city. Well, I definitely want to restore this. You should also not have touched that part. Can do an edit again. So I do want to restore this, so you must leave the minuses. And this plus. What about that plus? This probably corresponds to a minus here, or no, it just corresponds to this thing really actually. That's confusing. Let's swap those two. Well, maybe add a plus here, or maybe it doesn't accept that. Adding a plus is not allowed. What a lie. Why not? How does that not apply, man? I just did what it says. To remove plus lines, make them a space. Well, I made a space of this. Oops. Nope, doesn't want to do it. Nobody knows what it even means. Discard this hunk from the work tree while you are restoring. What the? How does that mean anything? I think discard hunk would mean do not apply, which means do not restore. But they should really use a different wording there. I'm gonna discard, whatever. What is this? No. Oh, wait a minute. If I say no here, I probably should have said no here. Or did I reverse it? What the hell, man? Yep, it removed it. Where was that thing then? That was below run over all intersection points and then add to intersection points WC. One was provided. Okay, maybe that's why it changed it. Was the parenthesis was on the wrong place? Well, maybe it should have moved the parentheses then. Okay, so it still works, but the code is a bit improved. And now I really want to get rid of the map, because there should be a better way to do that. index find. Yeah. It's always true. It's 100% impossible that it is not true. Intersection points. Oh, it's possible that it was 0. I mean, it's not possible that it is 1, but there's just no intersection at all. match, maybe. Edge. I would like to have an edge index. Yeah, I need a break. Falling asleep. Oh, fuck me. Why? Ah, shit. That is what really too stupid for words. Does not take this one. That is kind of stupid, I think. Well, okay. The night still stops it. I guess. We have the queen here, bishop here. I don't see a stalemate here. Fuck. Fuck. So maybe the king's still here. And he would have just promoted to a queen. Then you have king, 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 knight, queen, queen, bishop, bishop. That would be stalemate. Yeah. That walked with the king as well. Damn it, why did I give away my rook? So stupid. No queen check? Of course, you give a queen check here. Uh-oh. I give everything away. I think I should not play today. It's too tired anyway. Give away that one. Forget it. Okay, well, let's sleep instead or something.